Today we'll be discussing two additional criteria that we can use to prove triangles are congruent. So far we've discussed side angle side. Today we'll be discussing what are known as angle side angle and side side side. The diagram here in example 1 shows our criteria of angle side angle. Notice it's somewhat similar to side angle side, with the major difference being we know two angles in one triangle are congruent to two angles in a second triangle, and their included sides are congruent. So we'll need to be given two pairs of congruent angles and the pair of sides between those congruent angles. Let's skip down to example 2, where, like we looked at yesterday, we have a few examples with some given information. We're asked to prove a pair of triangles are congruent, and we need to list additional information that would need to be given to us in order to do that. So in the first question, they're giving us that angle ABC is congruent to angle DCB. Notice that this is a pair of angles in the two triangles that are overlapping. Looking at the diagram alone, we would be able to say that BC is congruent to itself by the reflexive property. We wouldn't be given this in the given information, but this is one of the properties or one of the reasons we can use and say is true just by looking at a diagram alone. This would be a pair of sides in the two overlapping triangles. So in order to use angle side angle, we would need one additional pair of angles to be congruent. And if I was to highlight triangle ABC and triangle DCB, since the pair of sides that are congruent need to be included between the congruent angles, the final piece of information we would need to be given is this pair of congruent angles, angle DBC and angle ACB. That would be our second pair of congruent angles, leaving us with angle side angle. Let's take a look at one more. In the next one, we're given that AD and BC are perpendicular. That's what this symbol here means. So in my diagram, I would be able to draw in right angles, and as a result of that, these angles would end up being congruent as well. So in a couple steps in a proof, this would lead to a pair of congruent angles. Similar to the last example, the two triangles we're asked to prove are congruent share a common side. That's side AD. So we would be able to say AD is congruent to itself by the reflexive property. This would be a pair of congruent sides, or an S toward ASA or SAS. In order to use angle side angle, we would need one additional piece of information regarding the angles. And the angles we would need to be given to be congruent are these ones labeled in red. Now, in the proof, I could be given BAD is congruent to CAD. However, in most cases, instead of giving you congruent angles so easily, I would give you a different piece of information, such as an angle bisector. So normally I would give you that AD bisects angle ABC, because this really checks to see if you understand what an angle bisector is or not. In either case, this would be an additional pair of angles, and then we would be able to use angle side angle. Next, we'll look at side side side. Notice in the diagram for number 3, we're given a diagram showing two triangles, and with the congruent markings, we have all three sides of one triangle are congruent to the corresponding three sides in the second triangle. This is what we call side side side, and it's our third way to prove triangles are congruent. Notice no information about angles needs to be given to us in order to prove triangles are congruent by side side side. Let's take a look at a couple examples where we're asked what additional given information would be needed in order to use side side side. So in the first example, we're told KM and JN bisect each other at L. So again, it's really important that you know what these vocabulary terms mean from earlier in the year. If segments bisect each other, then that means each segment intersects the other at its midpoint. So L would be the midpoint of both KM and of JN. And again, that's because we're told they bisect each other. meaning Km bisects Jn and Jn bisects Km. this really is giving us two pairs of congruent sides. Now notice in the picture, we would be able to say vertical angles are congruent. However, this wouldn't satisfy side, side, side. This would actually allow us to prove the triangles are congruent by side, angle, side. So the only way we can use side, side, side is if we were told that JK is congruent to NM. That would be our third pair of corresponding sides, so we would be able to use side, side, side. How about the next one? We're given that R is the midpoint of KL. If R is the midpoint of KL, then KR and LR would have to be congruent. So this really gives us a pair of sides in these two triangles we're aiming to show are congruent. By looking at the picture, we notice that the two triangles share side JR by the reflexive property. We can tell this just by looking at the picture, so we wouldn't need to be given this piece of information. That would be a second pair of sides. And for our remaining pair of sides, we could be told that JK is congruent to JL. Or perhaps I would give you this in a different way by saying something like JKL is an isosceles triangle. This would allow us to ultimately say these two sides are congruent as well, just with one additional step in our proof. And that would be side, side, side. On the next page, we'll look at a few formal proofs. So the first thing I notice in this proof is that they're asking us to prove the two triangles pictured are congruent to each other. So I don't really need to start by working backwards to identify the triangles. So I'm going to go ahead and write out statements and reasons. And to list my given information. M is the midpoint of HP. And angle H is congruent to angle P. Both are given. Now, I like to start with the information that tells us segments are congruent or angles are congruent, because I can immediately draw it in my diagram, and this counts as a pair of congruent angles toward SSS, SAS, or ASA. Now we really are on the lookout for which is going to be the quickest way to prove the triangles are congruent. We have lots of different choices of what we could use. The other piece of given information says that M is the midpoint of HP. So when we find HP in our picture, M is the midpoint, meaning HM and PM have to be congruent. Notice that I labeled it in my picture, and I'm making my statements and reasons match. A midpoint divides a segment into two congruent segments. Now I'm out of given information, but I don't yet have enough information to prove the triangles are congruent, since I only have one A and one S. Looking at my picture, I'm trying to find angles that are vertical angles, or maybe instances where I can use the reflexive property. And I notice that these angles at M are vertical angles. So HMG must be congruent to PMR, since vertical angles are congruent. This is a pair of angles, and looking at our diagram, we have two pairs of congruent corresponding angles and the sides between those angles, meaning the triangles must be congruent by angle, side, angle. And we'll write that in our proof as ASA is congruent to ASA. In the second proof, we're going to use properties of rectangles. Now, even though we haven't had our unit on quadrilaterals yet this year, you should be familiar with some basic properties of rectangles from middle school. So again, in this proof, we're asked to prove the triangles shown in the picture are congruent. So I'm going to go ahead and start with the given information. which is we have rectangle JKLM and diagonal KM. So in trying to prove these two triangles are congruent, we really want to think of all the various properties that are true for rectangles and think of which of those properties will help us get pairs of congruent angles or pairs of congruent sides. So the first thing I notice is that each of these triangles has an angle that's a right angle. And we know that because a rectangle has 4 right angles. So in my second step, I'm going to write that angle J and angle L are right angles, because a rectangle has 4 right angles. Good. This allows me to then say that these angles are congruent, because all right angles are congruent. And this counts as a pair of angles, so I'll put a little a out in parentheses in front of statement number 3. Now, thinking of my other properties of rectangles, I know the opposite sides of a rectangle must be congruent. So that means segment JK is congruent to segment LM, but also side JM and side LK are congruent too. The reason? Opposite sides of a rectangle are congruent. Now, since both of these statements are true for the same reason, I can include them in the same numbered step and just separate the two statements with commas. And this gives us 2 additional pairs of sides that are congruent. Now, looking at my diagram, I notice that I can prove the triangles are congruent by SAS, or side angle side. That'll be my 5th and final step. Now, some of you may have been wondering, could I use the reflexive property instead? And you definitely could. If you did, you could have proven the triangles are congruent by side, side, side instead. So there are 2 ways that you could have done this proof. Let's take a look at another. On the next one, notice we have circles drawn. Again, I'll go ahead and write out my statements and reasons. But in this proof, I'm going to want to use the strategy of working backwards. Because if I look at what I want to prove, they're asking us to prove angles CAB and DAB are congruent, the 2 that I've labeled in red. I like to have a goal of proving triangles are congruent first. So working backwards, I think the 2 triangles I want to show are congruent first would be triangles CAB and triangle DAB. If I could prove the triangles are congruent using SSS, SAS, or ASA, then we should be able to use CP-CTC to prove these 2 red angles are congruent. Next, we'll go ahead and write down the given information. We're given circle A and circle B. Now, thinking of our properties of circles, this would be helpful because if I take a look at circle A, CA and AD would both have to be congruent. And that's because those are radii of the same circle. So think of our constructions. When we draw a circle with our compass, all the points on the circle are the same distance from the center of the circle. The reason we use in proofs is saying all radii of the same circle are congruent. Looking over at circle B, we can use the same reason to say CB and DB are congruent. So I'll also include this in step 2. This is 2 pairs of sides toward one of our triangle congruence theorems. Looking at the diagram, since I'm out of given information, I notice that these 2 triangles also share side AB. So by the reflexive property, we know the 2 sides, the 2 segments are congruent. And this is our remaining pair of sides that allows us to use side, side, side. So in step 4, triangles CAB would be congruent to triangle DAB by SSS. And this was really our first goal. Once we've proven the triangles are congruent, since angles CAB and angle DAB are corresponding angles in these triangles, then they must be congruent by CPCTC. And that's exactly what we wanted to prove. Tomorrow we'll get some more practice with extra proofs in class.